Hi everyone, welcome back to Infinite Math Help Squared. In this video, we're going to be expressing a log as the sum or difference of logs. Specifically, this video is going to look at what happens when you have a root in the denominator. So the way we're going to handle this is we're going to change the root to basically exponential notation. So this square root of 5, remember, can be written as 5 to the power over the root. This is the square root of 5, so it can be written as 5 to the half power. As soon as it's written like this, now you can apply some different things, simpler things in my opinion. So the first thing that we're going to do is rewrite it. The log of base b of 3 times m times n, and for now I'll put it in the denominator so you can see step by step. So the first thing will be to bring this up to the numerator. So we'll just rewrite that as 3 times m times n to the 5. And when you bring it up to the numerator, hopefully you remember from previous classes or courses, then the exponent is going to change sign. Now, this is a little bit better for us because what do we have? We have all products here. If they're all products, then they are going to change into all sums. So let's rewrite this and just make sure that you don't miss anything. Make sure you have your base b. So we have that one of 3, and then add to it log base b of m plus log base b of n, right? And now this is a slightly different. We'll have subtract the half, right? Because the exponent, according to our properties, it will become the coefficient. So 5, oops, that one is supposed to be log. And then while I'm here, I'll just fix that one. Log base b of 5, and that's it. This is the original single log written as sum and differences of the log. Now, I have a second example that is a bit more complicated, but this is in fact the final answer. Okay. A little bit more complicated. It still has the square root in the denominator, but now in that root is also a difference. So you can actually approach it the same way that we did this one. You can actually rewrite that as an exponent and bring it to the top. I'm going to do it a little bit differently, and we're still going to use the exponents, but I'm going to do it a little bit differently. So the first thing that I'm going to do is I'm going to address this division right here, and I'm going to make it subtraction, right, according to our properties. So we will start with log base a. We will have, here's our numerator, but we are taking away the denominator. And for now, since we didn't change anything, let's keep it as the square root, and I'll just rewrite it step by step. Okay, so here's our first step. Now, the next thing that you can do is, yes, you can still rewrite that, we said, right? So let's rewrite the square root as a power of half. Okay, so that means that we rewrite this whole thing, but it's to the power of a half because it's the square root of the difference of x squared and y squared. Now, technically speaking, this is still equivalent to the original, right? And it's written as a difference. So technically, let's say it was a multiple choice question and it's asking for expressions that are equivalent, then this would qualify, right? But the one thing that I would say don't stop here, right? Don't stop here is because this can technically be written as a product, okay? What do I mean by that? That's the difference of two squares right there. So let's rewrite it. factored out. And you'll see what I'm talking about, whereas this is not prime, that there's a product in here. We have x squared plus y, oops, no squares. And x minus y. So see, this whole thing, x squared minus squared, actually factors out to this. So what does that mean? That I actually have that like this raised to the half power, right? And then this is why I'm saying don't leave it at that step. This is technically equivalent, yes. However, it's not prime, and you can argue that it's incomplete and that we want them, each of the logs, like if you look up here at the other example, these are all prime. Like this is just a 5. This is just an n, an m, a 3. There's no factors inside them. But over here, this did have factors. It was able to be factored out to x plus y times x minus y. So we're breaking it up. Now, we're almost there. What we're going to do is same strategy as before. We're going to use this exponent property as a coefficient. So let's rewrite that. So it's going to come out here, right? And when it comes out here, it's really important. This is going to be, because this becomes a coefficient, we have the log of base A times what's inside, right? And now what you can actually do is you can actually, since this is a product, then you can break that up as the sum, provided you are distributing your half. So we are going to rewrite this. This has not changed yet. But if I break this up and distribute, I'm left with a negative half times log base A of x plus y minus, because this is a negative half here, the log of base A of x minus y. Okay. And now hopefully you see that this is kind of coming to and simplifying. Why? Because we have terms that we can combine. We have, this is log base A of x minus y. This is log base A of x minus y. So since those are the same, we can combine their coefficients. Coefficient here is 1. Coefficient here is negative half. 1 minus a half is a half. So we end up with half the log base A of x minus y. And then this one was left over. We didn't touch that. So we have to keep that. Okay. And now this one would be considered complete. Obviously equivalent to the other two that we talked about, right? Like over here, over here. But this is actually complete and true sum and differences because of each of these guys right here just being prime. There's nothing to multiply to get to them. All right, so hopefully that helps and that clears up when you have roots in the denominator and you have to express as a sum and difference of logs. Till next time.